problem states, determine the speed of the elevator if each motor draws on the cable with a constant speed of 5 meters per second. So I've drawn out this helpful diagram to understand the question. First, I want to say that the motor is located on these two locations, point B and point C. What this says is that this part of the cable is being pulled up at a speed of 5 meters per second. Similarly, this part of the cable is also being pulled up at a speed of 5 meters per second. So what this diagram tells us is we have a datum, which is a reference point for our locations, our special locations that we determine on this pulley system. So let's start with S1. What does this mean? Well, S1 is the distance between the datum and the elevator, which is connected to the pulley system at the very bottom part of the pulley. So S1 gives us the distance between the datum and this location. So basically, like if I trace this out on the cable, it would be the distance between that and this. So hopefully that explanation is helpful. Moving on, we have S2. That is the distance between the datum and this pulley system, the part of the pulley system at this location. And then we have S3, which is the distance between the datum and a random point on the blue cable. Notice that we have two cables. This first one, which I'm tracing right now, this is cable number 1. And then we have another cable. Let me actually trace that better. So we have this first cable, and we have another one, which starts at point C, and I'm tracing it out like that. So I basically showed that we have two different cables. So S3 is the distance between the datum and a random point on the first cable, which we will show with the blue color. S2, on the other hand, is the distance between the datum and the other cable. So why is this useful? Well, in the problem, it says the motor draws the cable with a constant speed of 5 meters per second. This means that if we take the derivative of the S4 and S3 displacement values, then the derivative of those displacement values simply gives us the velocity. This will be useful because we have known velocities. So now what we want to do is get some sort of expression using these displacement values for solving the problem. Well, one way to approach that would be look at the length of each cable and describe them in terms of these displacement values. For the blue rope, let's say it's equivalent to L1. So how would we find an expression for L1? Well, we have this part of the cable here, which is simply equivalent to S1. So we would say L1 is equal to S1. And then aside from that, we have two other sections of this blue cable. We have this section, which can be represented as plus S1 minus S3. And then we have also this part, which can be simply represented with S2. So we would say plus S2. And now we have described the entire length of this blue cable. Now let's do the same for the green cable. So we have this part and this part. And notice the symmetry here. These two parts that I've just highlighted are the same value, right? They're the same length. So how would we represent that? Well, we could say S1 minus S2. So you'd say L2, which is the length of the green rope, is equivalent to 2 times S1 minus S2. And the reason why this 2 exists here, why we're doing 2 times S1 minus S2, is again due to symmetry. Moving on, we have this other part of the rope here, the green rope, which can be represented using S1 minus S4. So then that will be plus S1 minus S4. We have two nice equations here, but we can simplify these equations here. How, you may ask? Well, what do we know? We know that the derivative of S3 and the derivative of S2 are equivalent to 5. But we do not know the derivative of s1 and the derivative of s2. Do we care about the derivative of s2? Maybe. Do we care about the derivative of s1? Most certainly. Why? Because the derivative of s1 tells us the velocity of the elevator. Because s1 is here, so it's basically connected to the elevator. And if we find its derivative, then we have found the velocity of the elevator, which in the problem, it literally says find the speed of the elevator. So now let's do that. What we want to do is get these systems of equations, and we want to eliminate. So we want to eliminate S2 from them, because we don't really, we're not primarily interested in that right now. So let's grab this blue equation and let's rearrange it. So we have L1 is equal to 2S1 plus, or let's do minus S3 plus S2. And then rearranging this, we get S2 equals L1 minus 2S1 plus S3. So now let's plug this into this green equation to get a very nice equation. So we would say L2 equals 2S1. Before we plug in, actually, I'm just going to do this out. So that's going to be 2S2 plus S1 minus S4, which equals 3S1 minus 2S2 minus S4. Just making sure no mistakes here. All right, looks good. So then moving on, we just plug in the S2 expression here. So we get L2 is equal to 3S1 minus 2 times L1 minus 2S1 plus S3 minus S4. And that is pretty much the complete expression. We just need to do some algebra on it, or not algebra, but rearrange this. So then we get L2, 3S1, 2L1, we get 4S1 plus 2S3 minus S4. And then rearranging this, we get L2 minus 2L1 equals 3S1 minus, oh, actually, there's a mistake here. So this is supposed to be positive, and the other one's supposed to be negative, I think. Let's see. So this is positive. Negative times positive. That should be negative. All right. The rest of it seems good. All right. So we get this length value, and then we get 3S1 plus 4S1, which is 7S1. And then we have minus 2S3 minus S4. All right, now we have the expression all good and ready to go. So what we can do now is take the derivative of this. Well, how do we take the derivative of this? It's actually, it might look a little complicated, but let's see what this means. So we have the length of the green rope and the blue rope, right? If I were to ask you, you're taking the derivative of the length of these ropes, what would you say? Well, the correct answer would be, you would tell me that it is a constant. That it's equal to 0, because the length is a constant, right? The length of the rope doesn't really change. And if we take the derivative of the constant, then we get 0. So this will be equivalent to 0 equals 7 times v1, because the derivative of a displacement is a velocity, minus 2 times, we got v3 minus v4. So let's look at what these guys mean. So this is basically the derivative of each of these displacement values, right? So in the problem, it says, determine the speed of the elevator. So that is v1, the derivative of this displacement value. We know the derivative of s3 and s4. So we know v3 and v4. It is equivalent to -5 meters per second. The reason it's negative is because as the elevator is moving up, the displacement, the value of S3 is basically decreasing because it's going up, 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 and the S3 is decreasing. So if we go down here, we would say 0 is equal to 7v1 minus 2 times -5 minus -5. And if you solve out this equation, you would get that v1 is equal to -2.14 meters per second. Another way to represent this would be v1 equals 2.14 in the upwards direction. And this pretty much concludes the question. And I just want to talk about really quick what this means. So v1 is the speed of our elevator. We're able to calculate the speed of our elevator because we simply took the derivative of s1, which is a datum, which is a displacement that goes from the datum to the point where the elevator is located. And if we take the derivative of displacement, we get the velocity. And that concludes the question. Have a nice day.